Hey guys, welcome back to Calculus. Today we're going to be covering the product and quotient rules for finding derivatives. And you can find most of these examples on page 34 in your notes packet. So basically, whenever you're finding derivatives, there's a couple of options. Number one is the definition of derivative right here. So we can use the limit definition, and this works for every single function, which is nice because it's one rule for all functions. But if you have functions that start to look like f of x equals x plus 3 squared minus 4x all over 5x plus 2x squared, something like this, the limit definition can be pretty cumbersome, especially if you think about, okay, well, I'd have to substitute x plus h in for this, and then x plus h here, and then x plus h there. It can be a lot of algebra. So yes, that definition of derivative is nice because it does work for every function. However, it can be a lot of work. So that's our first option. Or we can apply derivative shortcuts. So derivative shortcuts are great because they're fast. The only issue with them is that there's a different shortcut associated with a different form of a function. But believe me, it's worth it to learn about the shortcuts for finding derivatives. So last class you worked on how to find the derivative in the form f of x plus g of x, so the sum or difference rule, or the power rule. So if you had something like f of x equals x squared, so you could just take to find the derivative, you could work with the power rule there. So there is a rule for that. Well, today we're going to be looking at functions that are of the form f of x times g of x. So this is called the product rule. When you have two functions being multiplied together, there's a rule for how to find their derivative. Or whenever there's a function written in the form f of x divided by g of x, there is a rule for that. And that rule is called the quotient rule. Now, you don't really need this flow chart. It's just kind of an image to help you follow along with what we're doing. But we're covering these two rules today, and then later on we'll have rules for more of these types of functions. So this is what you would see in your notes on page 34, the product rule. And it says the derivative of the product of two functions is the first derivative times the second. And I like to highlight the first and the second. So it's the first function times the derivative of the second. Let me get a different color. What color? Purple. Times the derivative of the second plus the second function times the derivative of the first. And then here is the product rule written out in a formula. So I would have the first function times the derivative of the second plus the second function times the derivative of the first. And I may be annoying you with my highlighting, but trust me, it will be worth it because you need to be able to recognize the two functions. So f of x is highlighted in purple, and then the functions associated with g of x highlighted in green. So part A has you do the derivative without the product rule and then with the product rule. So let's try this without the product rule because you did this last class. So let's do without the product rule first. And that would be if I have the function y equals 2x minus 4x, 2x squared minus 4x times the quantity 3x minus 5, then if I distribute this out, I can find the derivative without having to apply the product rule. So I could say y equals, I'm distributing, 2x squared times 3x would be 6x cubed. 2x squared times 5 minus 10x squared minus 12x squared plus 20x. So I changed the form, and now this function is in the form, let me scroll up, of right here, what's in the green box. So I can just apply the power rule at this point, changing my color so you can tell that I'm taking a derivative. Y prime, now I'm writing y prime because it says find y prime, equals the derivative of 6x cubed is 18x squared. Multiply the 2 times 10 to get 20. and subtract 1 from the exponent, so minus 20x. And then multiply the 2 times the 12, minus 24x. Subtract 1. Oh, I could have combined like terms, couldn't I? And then the derivative of 20x is 20. So combined like terms, y prime would be 18x squared minus 44x plus 20. And that's how you would find it last class and without the product rule. Now let me show you what that same product would look like, or the same derivative would look like with the product rule. So first of all, to apply the product rule, you do need to identify what your first function is and your second. So I'm noticing that what's in the parentheses here, that first thing is the first factor. And then the second factor is 3x minus 5. So the product rule allows me to find the derivative without having to multiply it through first. So let's say with product rule right here. So then y prime equals, now I'm going to find the first, let me change my color here to a purple. Okay. First, so I just copy that down, 2x squared minus 4x times the derivative of the second. So I'll take the derivative of 3x minus 5. The derivative of 3x is just 3. And derivative of negative 5 is 0. So first, derivative of the second plus the second. Now I just copy down my second function. I'm just going to copy down 3x minus 5 times the derivative of the first. And the derivative of the first is, let's see, the derivative of 2x squared is 4x. And the derivative of negative 4x is minus 4. So then from here, I've taken the derivative already. Notice I'm using my derivative notation. So I've already taken the derivative. I'm not rewriting. And then from here, I can just simplify it by multiplying everything out. So y prime equals, distribute the 3. I have 6x squared minus 12x. And then 3x minus 5 times 4x minus 4 is 12x. 12x minus 12x squared minus 12x minus 20x plus 20. So then combine like terms for y prime, I get 6x. Oh, I've got more than 6. I have 18x squared. It's like terms here. And then negative 12 minus 20 is minus 44x. And then plus 20. So notice I could do the problem with or without the product rule, but I get the same derivative. And also notice for this particular problem, it took about the same amount of work. So not bad. So sometimes you can choose to use the product rule or choose to not. And that's totally up to you. You can do whatever you prefer. At this point, you might prefer not using the product rule because you don't have to learn something new. However, sometimes it gets to be a lot. Like this is a lot already written out. So let's try this. First of all, I'm going to identify my two products. So that's the first in green. And the second, this time I will highlight in orange. And so that means I need to change this pen to an orange when I work it out. Orange. Okay. So now let's try, here's F. I'm going to find F prime. The product rule is to copy down the first. So 3x squared minus 2x plus 5, the first product, times the derivative of the second. So times the derivative of this, minus 20x to the third. Derivative of 2x to the third, multiply 3 times 2, you get 6x, subtract 1 from the exponent, squared, minus 2 times 7 is 14, subtract 1 from the exponent, x to the first. Derivative of x is plus 1, and the derivative of 2 is 0. So first derivative of second plus the second, so I just copy down the second, plus the second times the derivative of the first. So let's see. Derivative of 3x squared would be 6x. Derivative of negative 2x is minus 2. And then derivative of 5 is 0. So look, I have taken the derivative. Now I could, from here, I could go ahead and distribute everything out and simplify. I could simplify, but you're not always asked to simplify. Always asked to simplify. Sometimes you're asked a problem that says, just go ahead and find the derivative. You don't have to simplify at all. Just write the derivative in any form and you can just take it with the product rule and be done. If you don't use the product rule, you would be forced to distribute everything and then take a derivative. So that would be a scenario where it would be more work to not use the product rule. The other times, sometimes you're also going to be forced to use the product rule. And those are instances where they give you problems that involve sine and cosine. So you need to add this. Now this is in your notes, but it's on a different page. So just write this one down. We need to add to our knowledge. Let me get a different color. These two definitions. So these are two derivatives that you need to memorize. They're going to come up a lot. I can show you how to find these derivatives and I'll justify why they are what they are in a later lesson. But for today, you need to memorize forever and ever and ever, forever, ever, that the derivative of sine is always cosine. That's just a rule you need to remember. And the derivative of cosine is negative sine. Always remember that. So then sometimes, like definitely in Delta Math, is a problem straight from Delta Math. You'll be asked to find the derivative in any form, and you're going to be forced to use the product rule. So if I look at this problem, whenever you're looking at derivatives, the first thing you need to do is scan and say, okay, here's my problem. Do I see any products anywhere whatsoever? And so let me erase that. Okay, I'm scanning. 2x squared minus, there's no product here. Oh, but wait, x squared times sine of x, that is a product. Oh my goodness. So because there's a product within the function, then I need to apply the product rule to this product. So I've got the x squared part is my first term, and then the sine part, maybe I shouldn't use green. I'm gonna do that. Let's use blue. The sine part is the second part of the product. So when I go to find this, dy dx, I have to apply the product rule to this part of the function. And then here for the 2x squared, I can just apply the power rule because that's a term all by itself. So the derivative of 2x squared, multiply 2 times 2, I get 4x to the first power. But then I have to subtract me taking the product rule. So subtract, I'm going to subtract the entire product rule. So I'm going to do first, which is x squared, times the derivative of the second. So the derivative of sine, oh, what's that rule again? Right here. Derivative of sine is cosine. Plus the second, which is sine, times the derivative of the first. So the times the derivative of x squared, which is 2x. So here is the derivative in unsimplified form. So sometimes it's okay to answer it unsimplified. When it says in any term, any form, you can just go ahead and enter it the way that it is. But if it does say to simplify, then you'll need to simplify as much as you can. So let's go ahead and simplify this one. Dy dx equals 4x. The first is just 4x. I'm going to distribute this negative. So minus x squared cosine of x plus, now this is sine of x times 2 of x, but it's more common to write the 2x first. 2x times the sine of x. And I should get in the habit of putting parentheses around that x. There's my derivative. All right, and then let's do one more of those. So given the function Oh, and sorry, these two are not in your notes packet. Given the function y equals 4x cubed minus x squared times cosine of x, find the derivative in any form. So I'm scanning this function again and I'm looking for products, and I see right here x squared is being multiplied by cosine. So those are the two products, but then 4x cubed is just a term on its own, and I can apply the power rule to 4x cubed. So y prime, not y prime, they want me to find dy dx. dy dx equals the derivative of 4x cubed is 12x squared minus, then I'm going to apply the product rule. The product rule is the first function, x squared, times the derivative of the second function. So let's see, the second function is cosine. The derivative of cosine is negative sine. So x squared times negative sine, first derivative of second, plus the second, which is cosine, times the derivative of the first. So the derivative of x squared is 2x. And again, I'm subtracting because I'm subtracting that entire product. So then I will simplify everything. Dy dx equals 12x squared minus, let's see, if I distribute this negative times a negative is positive, so this is really plus x squared sine x plus 2x cosine of x. And this is the product rule.